All right, Unit 8, Day 2, the rational root theorem. So you look at all this on your papers. This looks kind of crazy, and it's the definition. And what does it mean, though? So basically, the rational root theorem is another method that we have for solving some equations that are kind of complex. If you think about what we've learned throughout the course of your high school and middle school careers, you get an equation like 3x equals 9, you divide both sides by 3. You get an equation like x squared minus 7x plus 12 equals 0. You can factor it. You can complete the square. You can use the quadratic formula. We've learned all these equation solving tools, but then once we get to these polynomials, the only thing we have ever really learned was to factor by grouping, and that's not always going to work. So the rational root theorem is going to be another tool that we have to potentially solve some equations. Now the thing with the rational root theorem is it's not always going to work. Not all equations have rational solutions. Okay, so if you have square root answers, imaginary answers, those are not rational, and if those are the only answers that your polynomial has, well, the rational root theorem won't help you. So it's not always going to help, but it can help, and we're going to explore those cases where it can help. So we have a polynomial here. The first thing you do is you factor the lead coefficient. We call that Q. It doesn't really matter what letter you call it, but the lead coefficient is a 3. So we have 1, -1, 3, and -3. There's always going to be the plus and the minus. 4 is 1, 2, and 4, and they're opposites. So here's how this works. It's not that x equals all these numbers, it's that x potentially could equal all these numbers. Now these numbers here, these are your, oops, excuse me, I have that backwards. These are your numerators. And these are your denominators. Every single one of these numbers gets put over top every single one of these numbers. So I start with 1. X could be 1 over 1. That equals 1. X could be 1 over -1. -1. 1 over 3. 1 over -3. Okay, I have now exhausted that first one. Now I go to this -1, what's going to happen here? -1 over 1 is just -1. -1 over -1 is +1. So if you do one of these two and you hit all 4 of these, you're going to get the pluses and the minuses. So I can move on to 2. 2 divided by 1 is 2. 2 divided by -1 is -2. 2 divided by 3 is 2/3. 2 divided by -3 is -2/3. And the last numbers here are 4 and -4. Let's put those over top each of these. 4 over 1 is 4. 4 over -1 is -4. 4 over 3, and 4 over -3. So this list here are my potential rational roots. Now let me go back to this second because I went kind of fast. I took this 1 and I divided it by this 1. That's where this 1 came from. I took this 1, I divided it by that -1. That's where this -1 comes from. You take every single one of these individually, put them over top every one of these. So what we're saying now, if there are rational roots, now what does it even mean to be a rational root? A rational root, a rational number is any number that can be written as a ratio of 2 integers. So basically what it means to us is it means fractions, no square roots. That's basically what it means. No square roots, no imaginaries. If you can write the number as a fraction of integers, that's a rational root. So these are our potential answers. They won't all be the answers, but they could be. One of them or a couple of them could be. All right, so let's take a look at it in action. First thing I'm going to do is I'm going to take that 2 and I'm going to break it down to ±1 and ±2. That's how to factor 2. Then I'm going to look at this 6. I'm going to factor it. It could be a ±1, a ±2, a ±3, and a ±6. Those are the numbers that factor, the integers that factor into 6 and 2. So the list of potential rational roots. 1 over 1, 1 over negative 1, 1 over 2, 1 over negative 2. The 1 has been exhausted. 2 over 1 is 2. 2 over negative 1 is negative 2. Now look at this. 2 divided by 2 is going to be 1 again. Negative 2 divided by, or 2 divided by negative 2 is going to be negative 1. We don't have to rewrite that. So now my 2's have been exhausted. 3. 3 over 1 is 3. 3 over negative 1 is negative 3. 3 over 2 and 3 over negative 2. 6 over 1, 6 over negative 1. 6 over 2 is 3, so we don't have to rewrite that. So here's my list of rational roots, potential rational roots. All right, so now what do? Now you're going to use synthetic division to figure out which one of these works. All right, while I was gone, I did this quick synthetic division. So as I did the synthetic division, I'm looking for this right here. If that's a 0, that means that one worked. That's a root. So what happened here was I took this equation here, I divided it by x minus 1, and it came out with this equation. 2x squared plus 13x plus 6 equals 0. Now what we have is a quadratic equation, which we already have plenty of ways of solving that. Maybe you can factor it, maybe not, but I'm just going to go right to the quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a Okay, as I did the quadratic formula, that actually came out to a perfect square. That means this was factorable. That's okay. Negative 13 plus or minus 11 over 4. The two answers that we will get are negative 1/2 and negative 6. So what are our three answers? 1, don't forget about that original rational root we found. 1, negative 1/2, and negative 6. Now we're going to try that again on example B. All right, first move is we are going to find our potential rational roots. Take 3, factor 3. You're going to get plus or minus 1, plus or minus 3. Take 4, plus or minus 1, plus or minus 2, plus or minus 4. Those are our potential, or those are our P's and our Q's, our potential rational roots. These numbers overtop these numbers. 1 over 1, 1 over negative 1. 1 over 3, 1 over negative 3. 2 over 1, 2 over negative 1, 2 over 3, 2 over negative 3, 4 over 1, 4 over negative 1, 4 over 3, 4 over negative 3. Now, I write plus or minus up here. I don't write it here because I'm going to need to test all these numbers, and when they don't work, I'm going to cross them out. I don't want to get a little confused with the plus or minus. I might cross something out. All right, what I'm going to show you now, I'm going to show you how to fast track this a little bit. So we're going to go into our calculators here, okay? Y equals, and punch this into your y equals. All right, so there we go, y equals. I punch that in. Next thing I'm going to do is I am going to go to second, this blue button, table, all the way over here, the graph button. And now I have a table of values. Now what I'm going to do is I'm going to enter these numbers in, and I'm looking at that y1. I'm looking to get a 0. 1 spits out a 27. That's no good. -1 spits out a 1. That's no good. 1/3 spits out a decimal. Negative 1/3, decimal. 2, nothing. Negative 2, aha, finally found one. So if you look at my calculator here, as the light comes on, that 2 gave me a 0. That's what we're looking for. That means 2 is a rational root. I'm sorry, negative 2 is a rational root. So that means we put that in the cubby up here. Now I'm going to do my synthetic division. 3, 13, 15. Careful, we skipped the x term, the linear term. Need a 0 in there and a negative 4. Okay, real quick, I'll do this for you. Bring down the 3. 3 times negative 2 is negative 6. 13 plus negative 6 is positive 7. 7 times negative 2 is negative 14. 15 plus negative 14 is positive 1. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Well, that better have worked. That was the whole point of testing in my calculator. That way I don't have to do all sorts of trials to figure out which one's a rational root. So now what do I have? I now have 3x cubed plus 7x squared plus x minus 2 equals 0. That's my remainder. So look, I took a 4th degree polynomial, I divided by a linear term, and it took me to a 3rd degree. Now here's the thing, we don't know how to solve this still. So here's the thing. This worked in the original equation. It might work again. It's possible it could be a double root. So if you find a root that works and it takes you down to an equation that you still can't solve with the quadratic formula with a factor by grouping, if you still don't know how to solve it, keep attacking with the rational root theorem with your new equation. This is called the depressed equation. But stick with negative 2. None of these are possible for this. These are all gone. Negative 2 could work again, and that's what we're going to try now. Negative 2, 3, 7, 1, negative 2. Bring down the 3. 3 times negative 2 is negative 6. 7 plus negative 6 is 1. 1 times negative 2, 1 plus negative 2, and look at that. It was indeed a double root. Now, why didn't I use my calculator for this one? I just wanted to see if it was going to work at first. If this didn't work, if this gave me a number other than 0 here, then I would have said, okay, I would have crossed that off, and then I would have entered this in my calculator, and then I would have attacked the way I found that negative 2 originally. And so now what do we have? We have 3x squared plus x minus 1 equals 0. Well, how do I know it starts with a 2nd degree term? Because you had a 3rd degree term. You divided it by a linear term, which we're always doing with synthetic division. So basically, you just drop the degree down 1. Now this here, I don't think that's going to be factorable, so I'm going to go right to the quadratic formula. Negative b plus or minus b squared minus 4 times a times c all over 2a. And 4 times 3 is 12. 1 minus negative 12. That is not going to be rational. So we're going to have negative 1 plus or minus the square root of 13 all over 6. Those are 2 of your answers, but don't forget, negative 2 and negative 2 are also answers. You don't have to write it twice. You don't even have to write this little dr up here, but we're just letting you know, hey, that was a double root. How many answers should we have? 1, 2, 3, 4, that counts as 2. Why 2? Well, it started out as a 4th degree equation, so you need 4 total answers. So I needed these 2 answers and these 2 answers. And that is Unit 8, Day 2.